Hello, welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says the wheel of a bicycle consists of a thin ring of tie and a rim connected to a hub by 8 spokes as shown in the figure below. The tie and the rim have combined mass of 3 kg and an average radius of 600 mm. Each spoke is a slender rod of mass M2 which is equal to 0.5 kg. The hub is a cylinder of mass M2 which is equal to 2 kg and a radius of 100 mm. A. Determine the mass moment of inertia of the wheel about an axis perpendicular to the page and passing through the center of mass G. B. Use the parallel axis theorem to determine the mass moment of inertia of the wheel about an axis perpendicular to the page and passing through point A. So that's the question we have. So the first thing you're going to do is that you're going to convert the unit for the length. You're going to convert the unit for the length to meters. Okay, so we have 600 millimeters and then we have 100 millimeters. So let's change these values into meters. So for R1, which is equal to 100 millimeters, if you multiply this by 10 to the power minus 3, you're going to get 0.1 meters. Okay, and then for R2 also, which is equal to 600 millimeters, you're going to get 0.6 meters. Okay, so first of all, you have to determine the mass moment of inertia of the wheel about an axis perpendicular to the page and passing through the center of mass G. So you are going to determine the mass moment of inertia, okay, of the axis which is perpendicular to the page and passing through this point G here. So perpendicular to the page is like a line protruding through your screen and it is perpendicular to your screen. So that's what the perpendicular to the page there means. So you have to find the moment of inertia of this whole body, okay, around the axis perpendicular to the page and passing through the center of mass G. So let's look at what you are going to do. So first of all, this is a composite body. Okay, we have the tie and the rim, we have the hub and then the spokes. So to find the mass moment of inertia, we must find the mass moment of each of the components and then we sum them up. So first of all, let's look at the tie and then the rim. So the tie and the rim will be considered as a thin ring, okay, which is what we have here. We consider the tie and the rim as a ring, okay. So we are going to use the formula for the mass moment of a ring to calculate for the mass moment of the tie and then the rim. So let's look at how you are going to do this. Okay, so for the tie and then the rim, okay, the mass moment of inertia will be equal to m r squared, okay, but in this case the radius will be r2, so we're going to have m r2 squared. So this will be the formula we will use to calculate the mass moment of inertia for the tie and then the rim, okay. And then now let's talk about the spokes. So for the spokes, we are considering them as a slender rod, okay. So we are going to use this formula 1/12 ml squared, okay, to calculate for the mass moment of inertia for the spoke. But for the spokes, you will have to do some small work there, okay. When you get there too, I'll let you know. And then finally, you have to determine the mass moment of inertia for the hub, which is considered to be a cylinder, okay. So for the hub, we are going to have half m r1 squared. Okay, so now let's talk about the length of the spokes. Okay, so for the spokes, we have the distance from the center of mass to the inner part of the rim, and then the tie to be R2, and then we have the distance from the center to the circumference of the half to be R1. So when you subtract R1 from R2, we are going to get the actual length of the spoke. So we are going to have this L here, the length of the spoke, length of the spoke to be equal to 0.6 minus 0.1. So that will give us L to be equal to 0.5 meters. So this will be the length of the spoke. Okay, and then there are 8 of them, so let's not forget about that. So from here, let's calculate the mass moment of inertia for each one of them. So I'm going to consider the tie and then the rim combined first. So they have a combined mass m1. Okay, so let me do this. I r, which is for the rim, and then the tie. So the mass, which is m1, is 3 kilogram. Okay, so that'll be 3 kilogram times r squared, which is r2 squared, and that's given to be 0.6. So we're going to have times 0.6 squared. So let's simplify this and see what you get. So 3 times 0.6 squared, so that give me a value of 1.08 kilogram meter squared. So this is for the mass moment of inertia of the rim and then the tie combined. So now let's find the mass moment of the spokes. So for the spokes, you are going to locate the center of mass of the spokes. Okay, so when I consider this spoke here, its center of mass will be somewhere at the center of the spoke. Okay, but you see that its center of mass is not actually at the point of rotation, or it's not actually at the point where the whole tie is rotating. So because of this, we will have to use the parallel axis theorem to find the mass moment of inertia of the spokes. So what we do is that since we are applying parallel axis theorem, we must know the distance from the center of mass, or the distance from the axis of rotation. Okay, the distance from the actual axis of rotation to the center of mass of the spokes, which will be this distance here. So you must know that distance. Okay, so when we know that distance, we can use the parallel axis theorem to find the mass moment of inertia of the spokes. So now you know the length of the spoke, okay, to be equal to 0.5. Okay, so we need, let me indicate this very well, we need this half length of the spoke, okay, plus the radius of the half to give us the distance of the center of mass of the spoke from the axis of rotation. So half of the length of the spoke would be 0.5. So let me say D equals 0.5 divided by 2, okay, plus the radius of the half, which is R1, okay, and then that's given to be 100 millimeters, which is 0.1. So let's simplify this and see what we get for D. So we have 0.5 divided by 2 plus 0.1. That gives us a value of 0.35 meters. Okay, so this would be the distance. Now let's use the parallel axis theorem to find the mass moment of inertia of the spoke. So we are going to have ISP, and then there are 8 spokes. Okay, so we are going to have 8. Okay, 8 multiplying 1 over 12. Okay, 1 over 12 times ml squared. ml squared, okay, plus the mass of the spoke, okay, times the distance d squared. Okay, so now let's substitute in the values and see what we will get. So we have 8 here multiplying 1 over 12, and then we know the mass of the spokes to be 0.5, so we have 0.5 here, and then the length to be 0.5. okay, so 0.5 squared plus the mass is 0.5, and then the distance d, which is the distance of the center of mass of the spokes from the axis of rotation, which is 0.35. So you have 0.35 squared. So I used 8 here because there are 8 spokes. Okay, so you have to multiply the mass moment of inertia of one spoke by 8 so that we get for the total spokes. So let's simplify this and see. So I'll do with the terms we have in the brackets first. We have 1 over 12 times 0.5 times 0.5 squared. So this will give me 8 multiplying 0.0104, okay, plus 0.5 times 0.35 squared. This will give me a value of 0.06125. So let's multiply the terms in the bracket by 8. So we are going to have 0.0104 plus 0.06125 times 8. So that gives me a value of 0.5732 kilogram meter squared. So that's the mass moment of inertia of all the 8 spokes. So now let's find the mass moment of inertia of the hub. So that will be IH. That reminds me of mass half GH. Please make sure you subscribe to the channel and also like the video. So we have IH to be equal to half m r1 squared. Okay, so you have this here. Okay, so now we know the mass of the hub. Okay, we know the mass of the hub to be 2 kilograms. So we're going to have 1 over 2 multiplying 2 times r1 squared, which is 0.1 squared. So let's simplify this and see. So half times 2 times 0.1 squared. That gives us a value of 0.01 kilogram meter squared. So this will be the mass moment of inertia of the cylindrical hub. So to determine the mass moment of inertia of the wheel by the axis perpendicular to the page and passing through the center of mass G, we'll have to add all these values that we have solved for. Okay, so let's look at that. So we have for the rim and tie, okay, which is this value. Then we have for the spokes, all the 8 spokes, okay, and then we have for that of the hub. So let's add these values to get the actual mass moment of inertia that we need. So we are going to have Ig to be equal to 1.08 plus 0.5732 plus 0.01. So let's simplify this and see. So 1.08 plus 0.5732 plus 0.01. That should give us a value of 1.663 kilogram meter squared. So this will be the mass moment of inertia of the fluid about the axis perpendicular to the page and passing through the center of mass G. So now let's go to the part B. Now let's look at how we are going to solve the part B. It says we should use the parallel axis theorem to determine the mass moment of inertia of the fluid about an axis perpendicular to the page and passing through point A. So now we are determining the mass moment of inertia of the fluid using the parallel axis theorem, okay, about an axis passing through point A and perpendicular to the page. So this is the point A that we have here. So you see that this point A here is at a certain distance from the center of mass, and then that distance will be equal to R2. Okay, so you are going to use the parallel axis term to solve this part of the question. So we're going to have the mass moment of inertia about the axis A, or the line passing through point A and perpendicular to the page, to be equal to the mass moment of inertia of the fluid about a center of mass G plus the total mass of the fluid multiplying d squared, which is the distance of the center of mass of the fluid from point A. We already found this value, okay, so what we have to find now is this value. So the m here will be equal to the total mass of the fluid. Okay, so let's look at how you are going to calculate that. We know the mass of the rim and then the tire combined to be 3 kilograms, so that will be 3, and then the mass of one spoke to be 0.5, and then there are 8, so we are going to have 8 multiplying 0.5, and then plus the mass of the hub, which is 2 kilograms. So we're going to have 3 plus 8 multiplying 0.5 plus 2. That gives us the total mass to be 9 kilograms, and then the D will be equal to 600 millimeters. Okay, sorry, the D is 600 millimeters, so that will be 0.6 meters. So let's substitute that into the formula. So we're going to have IA to be equal to 1.663, okay, plus the total mass, which is 9, multiplying 0.6 squared. So let's sum this up and see what you get. So we're going to have 1.663 plus 9 multiplying 0.6 squared. So this will give us a value of 4.9 kilogram meter squared. So this will be the answer. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.